Hello to everyone. My name is Dylan, and today I'll be talking to you about the bioprocess involved in the production of the beverage kombucha by Remedy Kombucha. Before we start, it must be noted that despite my best efforts to interact with Remedy Kombucha, they did not respond to my inquiries, leaving me to rely on established articles to supplement my knowledge. We are first going to talk about the history of kombucha. Kombucha is a traditional drink speculated to originate from Manchuria, ancient China. However, it is not known how recently it was formulated, as various sources have conflicting accounts ranging from 200 years ago to 2000 years ago. Over the last 2 centuries, its popularity has surged, becoming widely regarded as a health drink with supposed health benefits. So, the science behind kombucha. Production of the beverage involves fermentation of a symbiotic culture of bacteria and yeast, otherwise known as a SCOBY, in the presence of a sweetened tea. By allowing the SCOBY and the tea to rest over a period of time, the sucrose that is present in the tea is broken down into both acetic and gluconic acid. As a result, the microbiome that is present in the kombucha is a probiotic, stimulating prophylaxis effects in the body. Remedy Kombucha was founded by Sarah and Emmett Condon in Australia in 2012 after receiving their original SCOBY from German backpackers. The company has now been reported to control over 70% of the Australian kombucha market, putting it at more than $130 million turnover a year. Their main production factory is in Carrum Downs, staffed by 70 full-time employees, which produce over 10 million litres of kombucha a year. Remedy Kombucha is now sold at over 10,000 stores in Australia, with the company already having a presence in overseas markets, such as the UK. The international kombucha industry is set to grow strongly over the coming years, with estimations implying the industry will be worth 5.45 billion US dollars globally by the year 2025. This makes it an enticing industry for new companies to approach. So we are now going to talk about the upstream manufacturing of kombucha. This involves nutrient preparation, as well as strain selection, construction, maintenance, and optimization of our SCOBY. The first step in upstream processing is preparing the nutrients in a medium before adding the SCOBY. Sterilized water is pumped into a 500-litre vat and warmed to the optimal mixing temperature of 60 degrees Celsius. Sterilized water is used to avoid contamination, as microorganisms could be present in the water and interfere with the bioprocess. Once the water reaches the appropriate temperature, tea bags containing leaves of the Camellia sinensis or black tea are placed into the vat. The amount of leaves used is 1.5 grams per litre in 750 grams of leaves in total. From here, a worker in the factory, with the use of a stirring utensil, manually blends the tea bags with the water for a period of time. During the mixing process, the water becomes infused with the essence of the leaves, giving them a distinct taste and aroma. The solution continues to be mixed until the worker uses their discretion to decide if the solution has been appropriately infused. Upon completion, the leaves are removed and the medium is filtered using a fine filter to remove any debris that could have escaped from the tea bags. The remaining fluid is then mixed with sucrose, as the SCOBY needs a source of carbon in order to carry out fermentation. The amount of sucrose introduced into the fluid is roughly 70 grams per litre for a total amount of 3.5 kilograms. Once again, the fluid is thoroughly mixed for 30 minutes using a mechanical stirrer until all the sucrose is completely dissolved into the solution. After the sucrose has dissolved, the medium is ready to be inoculated with our SCOBY. After completing the nutrient preparations, the SCOBY must be introduced into the medium, which is the most critical step in the upstream processing. As previously mentioned, a SCOBY is a symbiotic culture of bacteria and yeast. Both of these organisms are able to carry out fermentation in an aerobic condition, making them suitable as choices to inoculate the medium. Acetic acid and gluconic acid producing bacteria are the prevailing prokaryote species in the kombucha culture. Acetobacter xylem has been shown to be the primary bacterium in the SCOBY mat producing acetic acid, gluconic acid, cellulose from carbon sources like ethanol and glucose. As for choice of yeast, a variety of species can be used in the SCOBY, including Saccharomyces cerevisiae, Saccharomyces belli, and Brettanomyces brasilinus. After selecting the bacteria and yeast for the SCOBY, the two species would need to be grown together in order to form the necessary SCOBY for production. However, once the SCOBY has grown to the required parameters needed for production, it can be used multiple times without needing to grow more. This is because with every batch of kombucha, a new film is formed from the existing mat, and this new film is used to make subsequent batches of kombucha. This allows for quicker production, as once the kombucha is ready to be packaged, the new film that was formed can be used straight away to inoculate the next batch. Finally, by altering the species used in the SCOBY for kombucha fermentation, production can be optimized. Since the bacteria used in the SCOBY is almost universally Acetobacter xylenum, the most variation results from choice of yeast. Depending on the choice of yeast, growth can be maximized during fermentation, allowing for easier inoculation of the next batch. Different strains of yeast develop at different rates and at different stages of incubation. Choosing the most suitable strain allows for the growth of the SCOBY to be properly optimized. Or instead, the strain of yeast can alter the pH levels in the beverages, which could add or detract from the flavor profile that the customers expect. So now that we have finished talking about upstream manufacturing, we're going to move on to the actual processing of the kombucha. This involves the bioreactor operation, bioreactor kinetics, and product formation optimization. After successfully preparing both the SCOBY and the nutrient medium, the producers can move on to the next part of the procedure. The nutrient medium is left to return to room temperature and then placed into a glass jar, which can vary on size depending on the manufacturers. Safety precautions must be taken to ensure that the glass jar is sterilized so there is no contamination of the samples during the incubation period. The sizing of the glass is not relevant. What is, however, is the amount of SCOBY added in a weight to volume ratio. A standard approach when inoculating the medium is using 10% weight to volume of the SCOBY comparative to the amount of medium. Once the medium is properly inoculated with the SCOBY, a cloth is placed over the top and the glass jar is sealed with a lid. Additional steps are taken to ensure that the seal is airtight because of two reasons. First of all, both organisms in the SCOBY are anaerobes, requiring the absence of oxygen in order to carry out their metabolic functions, which is the fermentation process. Secondly, ensuring an airtight seal will once again reduce the possibility of contamination from outside sources. Following on, the sealed inoculated medium is left to incubate for up to 30 days, although incubation times will vary between producers. While incubating, it is necessary to maintain the temperature of the inoculated fluid between 18 to 26 degrees Celsius. The temperature range has shown to allow the SCOBY to operate at peak metabolic functions while incubating. When incubation time is completed, the product will be ready for downstream processing. So we're going to move on and talk about bioreactor kinetics. Due to the nature of production for kombucha, the bioreactor kinetics are quite limited. This is because the inoculated tea is in an airtight glass container with no actual movement of liquid inside, instead staying stationary for an extended period of time. Next, we're going to be talking about product formation optimization. A multitude of factors can be altered during the production that can optimize product formation. As mentioned in the upstream processes, the choice of organisms can play a large role in the taste produced in the kombucha. However, there are other factors that also play a major role in the outcome of the product. One such factor is the interfacial area of the glass container and how it affects the titratable acidity. As a result of the fermentation process, there can be substantial amounts of acetic and gluconic acid. That, in high doses, is not safe for consumption. By decreasing the interfacial area, there is more titratable acidity that can be nullified in the final product. This allows for more usable product after the incubation period, avoiding high levels of acidity. Another large influence on the usable amount of product is the time allowed for incubation of the tea with the SCOBY. Throughout the incubation time, the sucrose present in the mixture is broken down by the microorganisms in the SCOBY into fructose and glucose, eventually resulting in acetic and gluconic acid. Therefore, the longer the medium is incubated, the more acidic it will become, and this can create an issue. If the mixture becomes too acidic, it may not be safe for human consumption, making the end product unusable. Therefore, manufacturers must adequately plan the incubation time so that the product is safe for consumption. And with that, we are finished with the processing of the kombucha and we move on to downstream manufacturing. This includes harvesting, product separation, further modifications, and formulating and packaging. So first of all, we have to harvest the kombucha. Upon successful incubation of the tea in the SCOBY, the glass jars are unsealed and opened. The SCOBY is carefully removed from the jar as to not let any of the debris remain that could cause complications when separating the product. Careful handling of the SCOBY is also necessary as it can be reused to inoculate future batches of tea, accelerating production. Once the SCOBY is properly removed, the liquid that remains can move on to the next step, which is product separation. Despite efforts to minimize the presence of debris, there will inevitably be trace amounts still lingering in the fluid. It is vital to remove these before the final product is sold to customers, as it can be unsafe to consume. The primary method for separation of the debris from the final product is filtration using a microfiltration cell. In doing so, leftover fragments of the leaves and the SCOBY are removed. If filtration is unsuccessful, there is a secondary option available that separates the remaining debris from the product even further. The mixture can be placed into the industrial centrifuge and set to 4000 RPM for 5 minutes. Thereafter, the supernatant produced should be devoid of any of the debris as it is all settled in the precipitate at the bottom of the centrifuge. The supernatant is carefully extracted to not disturb the precipitate and deposited into another container. With the product now separated, it can move on to further modifications. As kombucha is becoming more widely consumed, consumers are looking for larger variety and flavors of kombucha. Therefore, it has become necessary to introduce a wide variety of flavors to satiate this desire from the consumers. Currently, on the Remedy website, they offer 7 distinct flavors ranging from crisp apple to raspberry lemonade. To alter the flavor of the kombucha, organic concentrates of the desired flavor are introduced into different batches of the kombucha after they have been filtered and centrifuged. These various batches are stirred thoroughly using mechanical stirrers to ensure the flavor concentrate is distributed uniformly throughout the mixture. Finally, since the kombucha has undergone fermentation in a sealed container, it will naturally be carbonated. The buildup of carbon dioxide is a byproduct from the fermentation metabolism, and unable to escape, it becomes dissolved in the kombucha. This helps the manufacturers avoid having to spend time and resources in order to carbonate the beverage themselves. At this stage, the kombucha beverage itself has been completed, and what remains is simply to package the beverage. The various flavored batches are sealed off and the liquid is pumped through an automated system, transporting it to various sections of the factory for bottling. The automated system additionally transfers the exact amount of liquid to each bottle on the conveyor belt and creates an airtight seal with the lid. The sealed bottles continue along the conveyor belt to receive labeling and packaging, eventually reaching the end where they are ready to be distributed to outlets. And with that, the production of kombucha has come to an end. However, the safety and regulation of kombucha must still be discussed. Kombucha has largely been regarded as a health drink that has been noted to provide health benefits such as prophylaxis effects in the body. Nevertheless, consumption of kombucha has raised some safety concerns due to suspected liver damage, metabolic acidosis, and cutaneous anthrax infections. Another issue that is associated with the production of kombucha is regulation in regards to alcohol content. A byproduct of the fermentation process is ethanol, and although its concentration might not be as high as the acids, it is still present. If manufacturers do not control the level of alcohol in the beverage, there can be regulation issues. When kombucha products contain higher than 0.5% alcohol, which is the legal limit for non alcoholic drinks, they are classified as alcoholic beverages and are subject to relevant federal and state regulations. A consequence of this is that manufacturers need to manage the alcohol levels in the product to avoid regulation issues. Thank you for listening to this presentation.